for this very interesting, not interesting, but important forum. Okay, chips, ties, and sovereignty, India-Taiwan semiconductor collaboration in the Indo-Pacific region. Let me offer you a brief background of this event, okay, that is organized by ICCS research group under the theme, Chip Era and Digital Governance. To us, the chip war that we are witnessing today is not only simply a technological rivalry or a replay of the Cold War between the United States and China. It actually signals a strategic reconfiguration of global governance and capital operations that depart from the patterns of the 20th century, shaping the contour of a new world order. Semiconductors stand at the very heart of this transformation as a material foundation of all modern industry. Chips determines not only economic growth, but also the autonomy and security of nations. The stability of semiconductor production and supply chain has become indispensable to every state's sovereignty and perhaps even survival. Chips are more than components. They are infrastructures of power. They enable algorithm, computing, automation, design, memory, execution, and of course, the rise of generative AI. Crucially, they are also rewriting the logic of warfare and national security, from drones, cyber attacks, to disinformation campaign. Infrastructure sabotage, rare metal extractions. Okay, I'm looking at people in the waiting room, so maybe the office should handle that. And technological blockade, digital currency monopoly, automated information warfare, semiconductor underpin an expanding arsenal of geopolitical strategies. On this material ground, the industry mobilizes state support, activate geopolitical alliances, and accelerate its own expansion. It is within this context that we initiated our joint project, Chip Era and Digital Governance, Geopolitics, National Strategies, and the Operation of Capital at ICCS, our center, but in collaboration with TARM, Transit-Asia Research Network, with countries in mostly East and Southeast and South Asian countries, but also Europe. As part of this initiative, we have proposed a series of forums for the fall semester, starting from last spring semester and fall semester. Today, this is the 6th forum, okay, throughout this series. We address themes such as semiconductor industry and geopolitics, smart cities and information manipulation, surveillance regime and citizenship politics, platform governance, gig labor, and the possibility of solidarity. It is within this framework that we have also established a collaboration between the International Center of Cultural Studies in Taiwan and the Center for Studies in Social Sciences, Calcutta, India, under this ICSSR and STC project for 2 years, titled as China's Digital Silk Road and Chip-Based Geopolitics, a critical analytical study from the Indo-Taiwan perspective. So the collective research project explores the critical stakes of semiconductor geopolitics in our region. Today, This forum continues this effort, focusing on the emerging conditions of India-Taiwan semiconductor collaboration and amid rising Indo-Pacific tensions. I wish to thank Dr. Poonam Sharma for her leadership in organizing this event. And it is our honor and pleasure to have Professor Rosinka Chaudhuri as our co-moderator, the chair and director of cultural studies at the Center of the Studies of Social Sciences, Calcutta. So with that, I'm delighted to hand over the floor to Professor Chaudhuri. Please, Rosinka. Okay. Unmute yourself first.
Yes, thank you so much for that very warm welcome. And in turn, may I welcome everybody who is here today, present for this very important collaboration between these two institutes in Taiwan and India. The relevance and the contemporaneity of the work that is being done within this group was underlined for me by a report in the Economic Times just 2 days ago on August 30th. If you look at the Economic Times in India on August 30th, you will find a report telling us, and I'm sure this was beamed on all the TV channels as well, that our Prime Minister on Saturday visited a semiconductor plant in Sendai in Japan's Miyagi Prefecture, a day after New Delhi and Tokyo resolved to deepen cooperation in the critical technology sector. So this is apparently some, of some importance to our government. It is a very real concern because of what Joyce said, that it is in fact at the heart of modern technology, the semiconductor industry. So we very much value this collaboration between Taiwan and India because of the opportunities that it gives us to forge collaborations in our knowledge, research, and collaboration in the field of semiconductor supply chains, fabrication, testing, all of that is involved in the semiconductor industry. So again, a very warm welcome. I will now introduce the first speaker today, Professor Sanket Goel. Professor Goel is Head Center for Research Excellence in Semiconductor Technologies. He is the principal investigator for MEMS, Microfluidics and Nanoelectronics Lab. He is also professor, Department of Electrical and Electronics Engineering at BITS Pilani at the Hyderabad campus in Hyderabad. He has a very long and distinguished CV. He has not just led research projects, he's co-founded 3 deep tech startups, and some of his technologies have been co-developed and transferred to industry. He has won several awards. He has not only won several awards himself, his PhD scholars also, 4 of them, have won DBT, BIRAC, GYTI awards. Currently, as I said, he's the Dean of Research and Innovation and Head of Semiconductor, COE at BITS Pilani. And he's been a distinguished lecturer at many places, and he's on the editorial teams of several leading journals. With that brief introduction, I will hand over the floor to Professor Goel.
Thank you, Professor Chaudhuri. And thank you, Professor Liu, for your kind words and inviting me to present our work here. I hope my screen is visible and I am audible also. So I'm like an odd man here because we are engineers, and talking the language of social scientists is difficult, actually, and please forgive us if we don't justify next 20 minutes or so. So, Professor Chaudhuri, thank you so much for your kind words as well. I think we should talk more beyond this event also. So today I'm going to talk about, because time is short, sand to silicon to system. As we all know that the entire semiconductor baseline, which is silicon, more than 97, 98%, is made out of sand, which is almost 1/3 of the earth. So it looks like everything is free, but end of the day, we are talking about billions and trillions of dollar economy, which is of silicon, right? So, which is interesting, and I like this the word sovereignty in this particular session. I think it's a very, very, very important thing that how do we lead, and India Taiwan has a huge role to play. There has been a lot of history about it. So, I'll talk about academia's role in our India's semiconductor journey. So I'm from BITS Pilani, and on the left side, you can see the brief snapshots of our 5 campuses. And also I represent a very unique Center for Research Excellence in Semiconductor Technology, which is funded by our alumni and industry, and trying to add its own value. So without much background, I mean, I'm sure that we know these 4 points. Semiconductor is everywhere. I mean, if you think about our pockets, top pocket, bottom pocket, our bags, everywhere you will find semiconductors. So we're going to reach a $1 trillion market by next couple of years, if not already done so far. So which means that it will be sitting on like world's 10th or 12th economy if semiconductor would be a country. India is a turnaround point over the last 5-6 years, especially when government of India has launched India Semiconductor Mission with a $10 billion investment. And of course, a lot of ancillary things are also happening. And one important thing which we see is that there's a huge synergy which is happening between the policymakers, academia, industry. And one thing which I did not mention in the 4th column is the people at large. So basically, we're talking about P4 partnership, people, public, private partnership, P4. That is something which I always talk about. These are some of the devices. Probably as an engineer, we always talk about devices. So please forgive me if I'm not able to explain them today. But it looks like a lot of things which we are trying to do from the semiconductor perspective, and which will lead to a lot of applications. I'm not going to go in detail, but I'll share these slides with all of you so that we can save time and discuss more. So in Indian perspective, there is a huge market around $45 billion. And of course, the market will be more in next couple of years. So India will be sitting around 10 to 15% of entire semiconductor market in next few years with around 13 to 15% CAGR. 6 to 8 new facilities have been launched since the ISM has been announced by the government of India. And few projects are mentioned here: Dholera, Sanand, they both are in Gujarat. The SCL Foxconn, which was just launched 2 to 3 months back by the state, UP state government, very close to the new Noida International Airport. And a lot of government support is there by India Semiconductor Program. So just to tell you in brief that there's a lot of support which is happening through India Semiconductor Program, including government is offering 50% fiscal support for setting up CMOS-based fab facility. Compound semiconductor, again, another 50%. Another 50% to establish LCD, TFT, AMOLED display panels, and also 50% for semiconductor design, where India has already been on the top front. So not only we are focusing on the design, but also other major 3 verticals, be it CMOS-based fab, compound semiconductor, as well as the TFT LCD. So basically, these 3 will be the major verticals when we talk about the applications or the incentive which will be given by the government of India. As I told you that in year 2021, I suppose, a $1 billion initiative was launched. And the idea was to boost manufacturing and, of course, employment. I will give you the numbers of employment later. And Professor Chaudhuri mentioned about the Economic Times survey. So that's the very Economic Times have also talked about what kind of skilling manpower which we need in the next few years. I'll be showing those numbers, and we'll be partnering with Japan, Taiwan, US, of course, many more countries, but these 3 names comes to my mind. Of course, they are in alphabetic order, so please don't read anything beyond alphabetic here. So there are 4 major initiatives, of course, with the launch of ISM, specs, PLI scheme, and of course for the hardware and for software both. So these are the 3 to 4 major schemes which were launched by the government of India: production linked incentive and scheme for promotion of manufacturing of electronic components and semiconductors. So moving on, just a second, I have to toss it somewhere. Yes. Yeah. So there are a lot of incentive, of course, eligibility criteria, global competitive, all those are mentioned here. But more than what is mentioned on the ISM website and what ISM is looking at, the idea is that twofolds: economic growth, and the thing which I told you just now is a job creation. And the job creation number is very dicey and dynamic. When you talk about job creation from different sources over the last 3-4 years, you will find out that the number varies from 100,000 to 1.5 million jobs. And I believe that nothing wrong with that, because it depends on what you want to incorporate in that number. Are you talking about the direct number into the semiconductor design, fabrication, packaging, or some of the indirect numbers, ancillary numbers, which may be sort of used to create that ecosystem? And dependency we have to reduce. Currently, around 2/3 of semiconductor comes from outside India. So idea is that how do we bring it down to 1/3 in the next 4 to 5 years? Global tech hub, every country would like to have it, and certainly India wants to have it. And Industry 5.0, we want to go beyond 4.0, where we have achieved hugely in terms of developing the cyber physical system-based devices, parameters, IoT, AI enablement. Now, the idea is that how we can create a human-centric and sustainable technological approach that will be the major component of the Industry 5.0. Some of the milestone, I think I have already mentioned in my previous slide, but the idea is that the 3 major things which I told you, the LED-based compound semiconductor and the silicon-based approaches, and a lot of work is happening in this direction. So, but of course, every initiative, every good things come with challenges. So there are many challenges which government of India, not only government of India, but all of us have to address. The first one is the supply chain issue. We can talk about developing fabrication facilities or packaging facilities until we have the fundamental silicon wafer, fundamental substrate, whether it is 2-inch, 4-inch, 8-inch, 12-inch, 24, whatever, we cannot really move forward. And also not only the silicon wafers, but to components to create those advanced fabrication labs, clean room, and environments. It's extremely important. Still a lot of dependencies there from outside world to import raw material and equipment. It's a hugely capital intensive industry. So we need a huge upfront investment. So, I mean, coming from the academic perspective, even if we want to create a small clean room, like for example, in BITS Pilani Hyderabad campus, we have a clean room which is with the main area is around 600 square feet, and we are augmenting it to add another 1,000 square feet. So you can imagine that to make this extension clean room around 1,200, 300 clean room square feet size, we have to spend around 4 to 5 crore rupees just on civil work, and plus extra amount in terms of the new equipment, processes, training programs, and so on. So you can imagine that huge investment is needed to create even a small academic scale clean room to train some of those undergraduate or masters or school kids. So, but when we talk about industry scale clean room, we can certainly add 2 order or 3 order of magnitude very easily. Talent shortage is another gap, which I told you. The number, as I said, is very dicey. We can talk about few 100,000 to few million, depending on what we are going to include. Competition. Not only India and Taiwan, but all the countries are now pitching into this direction, because it's like a golden tongue, and it's like a huge economically stable area, semiconductor. So huge competition is there, and let's see who can win the race. So what is our country's potential, and how we can align the potential with that of Taiwan? Not only align, and how we can fill up the gaps. So you can see that there are more than 300 training institutions within India, and those training institutions are leveraged to create the semiconductor manpower. And the focus is, of course, to have the intellectual property creation and to have new startups. Like, for example, Government of India under the Ministry of Electronics and Information Technology, they have started something called Startup Hub. The idea is that the ministry, one of the academic institution, and one of the industry, it will be kind of a tripartite collaboration, and that will sort of support startup working in the broad area of semiconductor. And that's something we are also doing under CREST. I will tell you probably in a bit from now. Policies and incentive is a huge potential, and a lot of work has been done, evidently, because without that, the success story which has happened in the last 3 years would not have happened. Building global partnership, a lot of collaboration is happening, a lot of chip diplomacy in the sense that how we can work together, how we can fill up the gaps. I will also tell you from the academic perspective what kind of global partnership which we are doing in the broad domain of semiconductor, and of course the offshoots, for example, MEMS, sensors, memristors, different kinds of organic transistors, FETs. A lot of work is going on, not only to build the fundamental semiconductor acumen, but also how we can use them for other related technologies. So in terms of initiatives, I think I already told you that first Feb was announced in 2024 with around 1.26 lakhs crores of investment, I think, which comes out to be around 15 to $20 billion actually. If you can put together all the industry which has put together this investment. Tata is leading the fabrication packaging plant in Assam, in Gujarat. Global partnership which we are doing with Tesla, Taiwan's TSMC, Foxconn, Tokyo Electron, IBM, AMD, and with many countries. So market growth with these initiatives, we have seen a huge market growth, close to 20% CAGR. Just 2 days back, I was reading a news that the CG, this Thappa Group company, which has started the plant in Gujarat. So they will be producing first 100,000 chips next year, and they will take it to around 10 to 12 million chips in next 3 to 5 years. So you can imagine that this initiatives, this motivation is not just on piece of paper. We can see a lot of initiatives are happening on ground. As we speak today, the next annual Semicon India event has started today. Unfortunately, I'm not able to go because of some other engagement, but that is a huge single window event happening every year in India, and we see a lot of interest from different industry, academia, and government from different countries. So you can see some of the hubs which we have been attracting in Dholera, which is a new SEG in the state of Gujarat, and a lot of work is happening and perceiving to be happening in next 2-3 years. So as I mentioned that, sorry, I'm going in the back direction. So what is the role of academia? There are several text read statements you can see here, but I will explain it to you what we are doing to align these 6 broader areas of academia role, be it skill, workforce development, new initiatives in research and innovation, startup culture. BITS is already known to that, and what we are doing in terms of aligning our startup and entrepreneurship culture in semiconductor domain, a lot of industry academia collaboration. And we are working in policy ecosystem development, and this particular project is a huge evidence in that direction. We are working with many institutions, many industry, to create a joint center of excellence, joint engagement in semiconductor domain. So I will just take my remaining 5 to 7 minutes to talk about what we have done over the last 2 to 3 years. Of course, BITS have been working in semicon domain for last several years, but the COE started in July 2023, and we have developed many niche in this area. So without going too much in detail, so 2 needs: academia, industry, government linkages, build R&I capabilities, and number 2, skilled manpower. So there are 2 major areas. First area, of course, has 2 subsets, but we are trying to work on, if you consider 3 areas, all these areas. So you can see this is the picture from the Semicon India, which happened in Gujarat, in Gandhinagar, and we have been participating in all these events every year and getting a lot of outreaching, a lot of attraction from many people. I think, as I told you, that a lot of industry, some names are mentioned in the 3rd bullet points, and the idea is that to create high-skilled job in the next 5 to 6 years. So the semiconductor may not work on its own. It needs some standing, and those standings or those prominent applications are mentioned here, which are very well accepted, be it sensing, memory and storage, communication, security, and energy efficiency. So if you talk about the enhancement of semiconductor intellectual domain, it will impact all these 5 areas, of course, maybe beyond that. So to tell you about CREST and related semicon activities in BITS Pilani. So our central analytical lab was started around 10 to 12 years ago. And then we have a clean room in 2016. We started several new ancillary labs. We started launching new intramural projects, many startup-based initiatives, and started developing joint centers of excellence with the University of Buffalo, Iowa State, and RPI in US, all 3 universities. CREST was officially launched in around 2 years ago. And we have huge augmentation and intense outreach over the last 2 years or so. In terms of technical aspect, currently we in Hyderabad campus itself, total by end of this year, we'll have around 3,700 square feet of area. Please forgive me if I'm talking too much technical terms, but these class 100 and 1000 means that the level of cleanliness. Class 100 is of course more clean than class 1000. So eventually we can create a sub-micron or close to 100 nanometer kind of range of transistor when we will eventually augment our facilities by end of this year. You can see many labs, the equipments in clean room, high-end equipment which we have. We have invested tens of crores of rupees so far. And there are many other labs which are working on the foundation of the clean room. You can see some of the pictures here. And you can see some of the top class equipment which we have to start the fundamental clean room process to build upon entire transistor level. And to not only our faculty members, students are working in these clean rooms, but also we are getting a lot of interest from industry, local industry, not only to develop their technological niche, but also to train their own manpower. Now we are also getting a lot of interest from many colleges and many schools. Actually, I'm so amazed to see when we see some interest from schools that they would like to sort of create a semiconductor syllabi into their school courses. So, but when we talk to these kids, whether they are from schools or colleges, we have seen that many of them have not even seen a silicon wafer. How does it look like? So this really amazed us or further motivate us that I hope we are going in the right direction. So some more tools, probably I'll not go too much in detail, but not only working on the fundamental fabrication and design and packaging, the India, which is known in the design simulation, we have been augmenting those facilities. Some names are mentioned here. Of course, I will not read them verbatim. So a lot of, as I said, a lot of interest is there, be it the famous Girls Boarding School in Gwalior, also the Northeast, one of the Northeast famous university. So a lot of interest we are seeing from different quarters, school, colleges, engineering colleges, industry both ways, not only train their employees, but also to do something together. So we are seeing a lot of things together. So far, we would have trained close to 2,000 such professionals. I would say professional, even to students also, because the moment they keep silicon in their hand, they become professional. So a lot of work which we are trying to do to invite many industry folks, many school and colleges. And we have not only signed MOU with the colleges like RPI, University of Buffalo, and Iowa State, but we have already launched joint PhD programs with these institutions. Like we have 2 joint undergrad program with the Buffalo and 1 PhD program where we already have 20 joint PhD scholars with Buffalo already. And some other companies we are working very, very closely. And then we do regularly monthly colloquia where we invite the top semiconductor leaders from different parts of the world. And of course, we do a lot of events, workshops, hands-on training programs. And we have been some of the snapshots of those programs we can see on your screen. On the education or academic perspective, we have launched several programs. Like we have been doing a packaging program for industry folks primarily. We do it weekend evenings. We have already done 3 times and we are going to launch 4th time, hopefully. So what we do is that we have 20 modules and in next 10 weeks, which means 10 weekend evenings, we can complete the entire cycle. So far, under this packaging course, we have trained around 800 to 900 people. We have launched a minor program in semiconductor for our students, and we're going to launch it for external awards. Recently, we launched a very unique master's program in semiconductor. So I heard that already 150 students have taken this program since we have launched it just fresh this year. As I said, joint COE with the University at Buffalo, collaboration with industry, and so on. I spoke about the Mighty Startup Hub. So we have already launched that, and we have already supported few startups under this Mighty Startup Hub, which we have been running in collaboration with Micron. Yeah, so that's last slide. So our way forward, how we can continue to add value to the missions and visions of Government of India and the entire landscape of semiconductor R&D, semiconductor policymakers and entities and passionate amateur people. And we are trying to build upon this. You can see some of the initiatives, some of the feature list which we have in front of us. And we hope that we can continue to add on our value. And we would like to learn from policymakers and scientists who are working in the social, societal benefits, how we can sort of further augment our work, how we can further directionalize our work to see if we can do something even better. So this is our team. We have two professionals, the other three professionals now, full-time professionals. Of course, there is an associate head in each campus, and we have a clean room with the full-time staff. So a lot of work is going on in the overall overarching domain of semiconductor and nanotechnology. Thank you so much.
Thank you, Professor Goel. So with that, we shall move on to the second presentation, which is a joint presentation by Professor Vivekananda Mukherjee and Professor Pranab Kumar Dash. I will briefly
I have a small point actually before I have a meeting at 12:15. So really, I'm not sure I can join again, but I will try. So thank you so much for giving me this platform, and thank you so much once again.
Thank you so much, Professor Goel. So Professor Vivekananda Mukherjee is a professor at the Department of Economics and Finance, Birla Institute of Technology and Sciences, Pilani, at the Hyderabad campus. Before joining BITS Pilani, he taught at Jadavpur University, the University of Bardhaman, and Ramakrishna Mission Residential College, Narendrapur. He has been a postdoctoral fellow at INRA in France and at Catholic University in Belgium. And he has been on visiting fellowships subsequently at many universities, including at Sweden, France, Germany, and Monash University, Australia. He's published nearly 60 papers in reputed international and national journals and edited volumes. His area of interest is applied microeconomics, public economics, and institutional economics. He's one of the associate editors of the South Asian Journal of Macroeconomics and Public Finance, and he's also on the editorial board of the Journal of Sustainable Finance and Accounting. Pranab Kumar Dash has been working at the Center for Studies in Social Sciences, Calcutta since 1992, July, just a few days ago. His area of teaching and research is banking and finance in macroeconomic models in theory and empirical application. He has published extensively in reputed national and international journals. I will not give you all the names of the venues of his publication, but he has also, of course, published in edited books published by Oxford and Macmillan, and he has himself edited a book which was published by Orion Black Swan. He also has experience of teaching and research in reputed foreign universities in the UK, at The Hague, and at Paris. He has attended and presented papers at many international conferences worldwide, and he has received research grants from CEDES Argentina, IDRC Canada, the DFID UK, and many Indian institutions. Lastly, I would just like to mention that he has also worked as the country expert for the World Bank and the Ministry of Finance, Government of India project on fiscal modeling for India during 2019 and 20. So a very warm welcome and the floor is yours.
Hello. So I think, okay, so the screen is going. Okay, so thank you very much, for this opportunity of presenting this thing, a study on semiconductor industry. So we are going to talk about India's problems and prospect. So this is a joint work between Pranab Kumar Das and myself, but I'll be presenting the slides, and the questions will be taken up by Professor Das. So all the difficult questions, so that you will have in your mind, so just target them to Professor Das. So so this is the thing, and we are so far Professor Goel actually had a good start of this topic, and he talked in details about India's semiconductor industry, and mostly this was about prospects of India's semiconductor industry. But as economists, we are skeptical about many things. So I will also talk about some, the problems. Okay, so that can happen. So we'll in our work we look at both problems and prospect. So first I'll talk about the prospect, and then we'll come back and talk about some problems. Okay, so that is there. So I'll start with, and the perspective of Professor Goel was a perspective of an engineer, and now we are social scientists. So basically we look at so because we are new to the the technical thing, which is the space of semiconductors. So I'll start with beginning. We look at the semiconductor value chain, and we have a brief look at the history of development of semiconductor industry around the world. Okay, and then I come back to the India's semiconductor industry. So this slide actually gives you idea about the semiconductor value chain. So what is happening, semiconductor is basically an input, okay, in the production process. And this input is actually the input to some box companies. Okay, so the industry professionals, they talk about box companies. So the chips, okay, so they have to be inserted in a box. Okay, so this box can be anything. So it can be car, it can be LED TV, okay, or it can be mobile phones or anything. So sometimes these are called, the box companies are also called the OEMs, okay, the original equipment manufacturers. So these are electronic equipment manufacturers. So they will have some design of chips for their products. And so this is actually given to, when they need a design. So then, so this design order goes to the fabless design firms. And these fabless design firms, they have many inputs in the production process, and ultimately they will design the chip. And then this design chip will go to foundry, okay, for production, where, the wafers are produced with, this chip design imposed on them. Okay, and then, so from foundry, it will go to the packaging, assembly, and testing things. So sometimes this is also called OSAT, okay, the outsourced semiconductor assembly and testing. So that is the meaning of OSAT. And, so ultimately it goes back, okay, to the box companies or OEMs, okay, for the final, integration in the final product. Okay, so that's the way the value chain runs. And similarly, just like, I talked about the fabless design firms have many tools like software, EDA, and all these things. So similarly, foundry also have, a number of processes inside it. So for example, so there is a lithography unit, so which actually, impose the design, okay, on the chip. Okay, so there is something called doping, etching, and all these things. So all are clubbed together in my definition of foundry. So initially, if you look at the history of semiconductor industry, so it developed in US, okay, and it developed just after the Second World War. And the major, the thrust of the demand for the semiconductor chips, okay, so that actually the, the thrust for demand of semiconductor chips and the designs and all these things actually came from US Defense and Space Program. So they wanted to develop, the precision weapons, okay, and for space technology for controlling the spacecraft and all these things. So from there, the demand came, okay, to the semiconductor industry, and that's the way it developed in US. So initially, all the chip companies, in US, for example, initially it was, I think Fairchild Semiconductors. Okay, so that was the first one. So then you had Intel, Texas Instruments, and all these things. So all of them were actually vertically integrated firms. So what do I mean by vertical integration? So all these steps I have talked about, so these are actually, all these steps are done in a single company, okay, a single entity. So that is a vertical integrated firms. So these Intel, Texas Instruments, and even Apple, okay, so till 90s, okay, so they were big firms, okay, they are producing, doing all these steps together, okay, in the single company, okay, so that's a vertically integrated firms. But, the outsourcing of one part of this supply chain, so that is a packaging, assembly, and testing, that started, long back in end of 1960s and beginning of 1970s, just after the Vietnam War. So this outsourcing of assembly and testing, so that was done in the Southeast Asian countries. So in fact, there is a very book by Chris Miller. Okay, so the name of the book is Cheap War. So Chris Miller tells that initially all these outsourcing were done in the Southeast Asia, so in the US military bases. Okay, so if you look at the location of US military bases, so all of them got some, outsourced production of assembly and testing. So for example, it was in, it was in Japan, it was in Hong Kong, okay, Singapore, Malaysia, Taiwan also. Okay, so it started, and what was the motivation for that? So initial motivation was that, to make up the image of US just after the Vietnam War. Okay, so in fact, we are, so kind of image makeover. Okay, the good things about US. Okay, so they are, outsourcing some production in Southeast Asia. So that's the way the outsourcing started. But, afterwards, what happens? So not only the, assembly and testing. So afterwards, what happens? So this design and, the fabless design and foundry. Okay, so these activities also got, separated, okay, from the vertically integrated form. And there, Taiwan actually played a major role. Okay, so we'll come back to this particular separation of design and foundry and the role of Taiwan in this. Okay, but so this is a latter phenomenon. So in fact, if you look at the company, the famous company of Apple, so Apple till 1996 or 7, I think 98, okay, so they were fully integrated, vertically integrated. So they started outsourcing a production to China, I think in early 2000s or so on. So before that, it was completely vertically integrated. Right. So the separation of design and foundry. So that's, that was a development. So that happened in late 80s and beginning of 90s. Okay. From there it started. And now, it's almost, very much prevalent, okay, in the semiconductor value chain. Now I'll come to that. But if you look at the value added by segments, okay, in the semiconductor production process, okay, so there you see that, so you have, the supply chain I have already talked about. Okay, and there is fab, so that is a foundry. So there is a fab tools, okay, so that is there. And then you have, the wafers. So if you look at, this production process, and suppose we are talking about a value of 445 billion, okay, which is the size of semiconductor, the value of semiconductor industry in the world in the year 2019. So if you share the value of these different segments of this industry, so then the sum of fab tools and wafer, if you do that, okay, so that would be nearly 55% of the total value created in the semiconductor industry. The major chunk goes over there. Okay, and then if you look at design, okay, so design will include, the design $132 billion, so that is there. Okay, so plus EDA and IP. Okay, so if you add them up, okay, so that would come around 35%. Okay, and 10% value is generated from the assembly, testing and packaging. Okay, so that's, the sum of ATP, which is $43 billion. Okay, and ATP tools, okay, which is $11 billion. Okay, so ATP industry, so this assembly, testing and packaging. Okay, so that we have talked about. So which was, initially outsourced, okay, to the Southeast Asian countries. Okay, so that actually, constitutes very small part of the entire value chain. Okay, so it's roughly 10%. So again, to remind you, foundry is around 55%. Okay, and fabless design is around 35%. Okay, in the 100% of this industry. So we have to keep this in our mind when we are, discussing the semiconductor value chain and, the role of India and Taiwan in it. Okay, so we'll come back to this point again. Now, if you look at the share of global semiconductor foundry production by location, the country location, okay, so I told you the story of, the history of semiconductor industry. So therefore, if you look at, and here we are talking about only about the foundry production, okay. Now, in 1990, okay, look at the, Southeast Asian countries, South Korea, Taiwan, China, and other, and all other countries in the world. So share of them in the foundry production was almost zero. Okay, so, and most of the chips were being produced in US, Europe, and Japan. Okay, so they covered the 100%. Okay, so then come back to the row and come back to 2025. So you can see that the US share is declining fastly, and Europe's share faster decline. Okay, so Japan is somewhat declined. So in 1919 it was 19%. Okay, but now in 2025, so forecasted was 15%. Taiwan's share was going up till 2020 very fast. Okay, and then it maintained that level. China, coming up in a big way. Okay, and in some other pockets, okay, in the world, you have some production. Okay, so you can see the importance of US is going down. Okay, and in US and Europe, the Western countries, so that is going down. So Japan is maintaining its share. Taiwan and China, they are coming up in a big way, and South Korea. Okay, so that is happening. And why this is happening? Because the semiconductor production, the foundry production actually shifted out. So these US companies, okay, so they outsourced all the production. So not only the assembly and testing, so which happened, started long back in 1960s. And after starting this, they found it, the US companies found that in fact, outsourcing is a very good business. Okay, in the sense, the efficiency of these Southeast Asian countries in assembly and testing was much higher than the efficiency in US. Okay, and afterwards they found that so the Southeast Asian countries are much more efficient, okay, in production process. Okay, in other segments also, like foundry and design and all these things. As a result of that, so you have increasing outsourcing of other things, okay, in these countries as well. Okay, so that's the way it has happened. So in a connection, now Trump is trying to getting back these things in US. Okay, but why outsourcing happened? Because so these countries were much more efficient, and that's the US companies found out. Okay, but now Trump is trying to moving back the wheel. Okay, so that's what is actually happening. Okay, so right now. Now, so look at the global semiconductor companies. Okay, so TSMC, okay, which is a Taiwanese company. So in the total foundry revenue, so it has the highest share. Okay, so that is 62%. Okay, so and the South Korean company Samsung, okay, and their Taiwanese companies like UMC, Global Foundries, US companies. But you can see that the share of the US companies is very small. Okay, the major share actually goes to Taiwan, okay, and South Korea. Okay, right? And TS here, power chip semiconductor manufacturing company. So that you should keep in mind, because PSMC is the company, okay, which is having a collaboration with, the Indian company of the Tata group. Okay, so to open a foundry in India. Okay, so I'll come back to PSMC once again. But remember, PSMC has, is a small player, okay, in the global foundry production. Okay, so I'll come back to this point, okay, when I discuss the Indian story. So there is a dominance of US. So even though most of the production is happening in Southeast Asia, but most of the technologies, okay, and these companies which are outsourcing this foundry and the fabless design and the testing and packaging. So these companies mostly, okay, are the US companies. Okay, so they are they have dominant share of the the value chain of the semiconductor industry. So the companies are owned by US. Okay, the production is happening somewhere else, okay, in Southeast Asia. Okay, so that is actually happening. So therefore the US companies have huge control, okay, over this the value chain that I have talked about. Okay, so that again we have to keep in our mind, and so that. Creates a lot of problems. So we'll come back to that. Now, let's look at the electronic industry value chain in India. Okay, so Professor Sanket Goel actually, talked about a bit about this. Okay, but so let me explain it a little bit. So what is happening over here? So there are different things. Okay, and so these battery-like things. Okay, with different colors, green, red, and all these things. So that actually tells you, the Indians' competence, okay, in these different parts of the value chain in the electronic industry. So first look at the product design and development. Okay, so here, the Indian competence is moderate. Okay, so here what kind of job is done? The design of electronic products based on the original equipment manufacturers' requirement and inputs. Okay, so they give order. Okay, and the design is done. The component manufacturing, so that includes, the production of semiconductor chips. Okay, here in India is very bad. Okay, the competence is very low. Okay, so nothing happens in India till now. Okay, so PCB, so PCB is printed circuit board. So that is, you have, moderate competence. India has moderate competence in this. Box build. So this, so this is an assembly of, the finished products into a box. Okay, so that happens in India. Okay, so we have high competence in this. Okay, and testing and logistics. So it's part of, so when the box is built, okay, so then, the product is tested. Okay, and then, it is, transferred to the original equipment manufacturer. So we are doing good in that. Okay, and alternative services. So then we do the servicing of these things. Okay, includes after sales support such as repair and maintenance of products. Okay, so there also India is, good, right? So that's, that was the situation in December 2023. So it is taken from a report which is published by Ernst & Young. Now, the domestic production of India. So you can see that starting from financial year 2017, okay, so in fact, there is a huge growth, okay, in the domestic production of electronic products in India. And this growth is driven, mainly by, the production of mobiles, okay, mobile phones. So right now, that, the manufacturing of, I think, assembly of Apple phones. Okay, so because of this China one strategy of Apple, okay, so Foxconn is, assembling mobile phones in India. So that shows in, the share of mobile phones. We have consumer electronics, so that is, the washing machines, TV, and all these things. Okay, so that's the CEA. Okay, so industrial use of electronics. Okay, so that is there, and then auto. Okay, so that is there. IT, lighting, okay, and the medical equipments. Okay, so all of them are growing. Okay, but the growth is highest in the mobile manufacturing. Okay, so that's the way the domestic production is growing in India. Okay, so that's good for semiconductor industry. So why I'm showing this? So if the domestic production increases, so then actually you demand a lot of chips and designs and assembly and testing. Okay, in the process. Okay, so that would create demand in this the component industries. Now, finished electronic goods production, if you look at, so the domestic production again, okay, is this blue part. Okay, so that is a production in India. Okay, and the gray part is actually the demand, okay, in India. And you can see that, so initially the demand in India in financial year 17 was higher than the production in India. So we used to import, okay, some, electronics product in India. But now what is happening? So it is expected that in financial year 2027, the domestic production will exceed domestic demand. Okay, and we will export electronic goods from India, okay, to rest of the world. And so this is driven by, again, the story of Apple will come. Okay, so Apple is exporting. Okay, the Foxconn is assembling mobile phones, Apple phones in India. Okay, and it is exporting to US. Okay, so that's the way export is growing. Okay, from the kind of things we are doing in India. Okay, Now, look at the incentives given, okay, in India by the government, okay, and I think Professor Goel has talked about these things in detail. So there is huge subsidy which is given by the Indian government. So initially, it was calculated that, you know, if you compare the manufacturing cost of electronics in India vis-a-vis China and Vietnam, so there was a gap of 9.1%, and Indian government was trying to fill the gap through different incentive schemes. Okay, and there you have incentives like, you know, 50% of the project cost, okay, and, you know, 75% of common facility centers cost, you know, so capital expenditure on these projects. And if you, you know, if you produce in India, so if it is a made in India product, okay, so then you get some, you know, incentive from the government. So that is 4% or 6% of the, you know, the sale value of the goods manufactured in India. So which is known as production linked insurance scheme. So which was started in 2020, and the objective of these things, okay, is to, you know, discover this gap in, the cost disadvantage that we have, okay, against China and Vietnam, okay, and to attract electronic manufacturing in India, okay, so that is happening. Now, if you look at India's semiconductor market, you know, so then actually, so 2022 is the actual and 2030 is the forecast. Okay, and you can see that, you know, so these different segments like wireless, wireline communication, wireless communication, computer, you know, so these things are, you know, expected to grow, okay, like this. Okay, and the maximum growth is expected to happen in wireless communication, the mobile phones again, okay, the consumer electronics, okay, and then automotive electronics and so on. Okay, so from these segments, actually, we expect more demand to come, okay, by the year 2030. Okay, so now look at the components. Okay, so remember the value chain I have talked about earlier. Okay, so I look at, you know, the situation of these value chains, okay, which is, you know, different components of value chain. Okay, so that is there in India and where we stand. So first look at the fabless design. Okay, now the fabless design, okay, is a design component. Okay, and here India has a strength. Okay, so India accounts for 20% of the world's integrated circuit design workforce, and that is about 125,000 individuals. Okay, 125,000 individuals. Okay, so Indian engineers are there. And we produce 3,000 individual ICs, okay, designed in India each year, and 15% of the global production of VLSI, so which is very large scale integration. So that is the meaning of VLSI. And almost every one of the world's top 25 semiconductor design companies, so they have their offices in India. Okay, so they have their R&D center in India, like Intel, Texas Instruments, NVIDIA, Qualcomm. If you go to Bangalore, so you'll see, you know, offices of all these companies over there. Okay, so India is also a hub of semiconductor equipment design, like Lam Research Corporation, Applied Materials. Okay, they are, you know, working in India. But the problem is that most of this design work is performed in India services. So this actually, what we do in India, we service a foreign multinationals. Okay, so the R&D is done. Okay, but we work for the American companies. Okay, so that's the way it works. The local design ecosystem has not developed because we don't have, you know, the electronics finished products. So we don't have Indian brands. Okay, so where, you know, the design specification doesn't come from the Indian companies. Okay, so all of them are foreign companies. So they order their design. Okay, and our engineers in India, so big number. Okay, so a lot of people. So they, you know, service these companies. So little value addition is done. Okay, in India itself, right? So, but, you know, the startups are, so there is a startup environment in India. So what Professor Sanket Goel was, you know, pointing towards, but, you know, the startups are coming up. Okay, but there is a problem with the, you know, the financing of the startups. Okay, because of venture capitals. Okay, so they rarely, you know, come up to finance these startups. Okay, because of the long gestation period. Okay, so that you have, okay, in these design firms. Okay, so it takes, you know, 7 to 8 years to make profit, okay, in these companies. Okay, and the failure rate is also very high. Okay, so therefore, you know, the financing is a difficult thing, although, you know, some incentives are there, okay, from the government of India. I'll talk about that, okay, as I progress. Now, if you look at the fabs, okay, so look at the, you know, the fab company. Right now, there is only one fab company, okay, which is there, you know, so they are in the process of having the production. So the construction of this company, Tata Group Fab, which Professor Goel actually showed the picture of, so that came up in a place called Dholera in Gujarat. Okay, and the technology, interestingly, is coming from PSMC Taiwan. Okay, so which has 1% share of global value in the industry. So it's a small entity, not like TSMC. Okay, so and UNC, the bigger entities in Taiwan. Okay, so but so PSMC is there. Okay, the technology partner of this product, and the aim is to produce 28 to 19 nanometer process. Okay, so which are legacy chips. Okay, which are used in automobiles, electronic, washing machines and all these kind of things. Okay, so we are not talking about the chips, very high-end chips like sub 7 nanometer process. Okay, so which is mostly reported in the newspapers. We talk about very sophisticated chips which are required in AI and all these things. So we are that this Tata Group company is not trying to do that. Okay, so it is trying to produce 28 to 90 nanometer NM process. And so this is actually, we are not talking about the level of TSMC, but of course I have to know more about, the activities of TSMC, but, TSMC is more famous, okay, for the, 7 nm and, below that, 2 nm, 1.5 nm processes. Okay, but here we are talking about 28 to 90 nm processes. Okay, so we have to be very clear about that. Okay, so here, the first production is supposed to begin, okay, by 2026. Now, the majority of the chips, but so there is not everything bad about production of legacy chips. Okay, so because majority of chips sold worldwide are legacy chips, with 2/3 of them using technologies which are commercialized before 2005. So the technology which is being used in this, the farm, okay, so which is established in Dholera, Gujarat. So that is an old technology. So we are not talking about the cutting edge technology in the foundry production in India. Okay, so I have already talked about this. So these are the companies. So they actually use the legacy chips. Okay, the global automotive semiconductor market is expected to grow from $38.7 billion to $116.6 billion by 2030. So almost 3-fold increase is expected. So we are expecting the demand for these chips produced by the Tata Group company, okay, is expected to be there. Okay, so expected to grow. Okay, so that's a good thing. So as India expands, and also a lot of internal demand is expected to be generated because India is also growing in many things. Okay, so we are revamping our electric grid. Okay, so EVs are coming up in a big way. Okay, and there, in fact, you need these legacy chips. Okay, so and afterwards, so after probably the plan is that so after we develop competence in the production of these legacy chips. Okay, so we move up in the technology ladder. Okay, and think about producing more sophisticated chips. Okay, which will be used in mobile phones, the laptops, and the new things like AI and everything. Okay, so so that must be the plan. Okay, so or that should be the plan. Okay, in the fab production process. Now for the ATP, okay, the Micron OSAT facility, okay, so that came up in Sanand, Gujarat. So there is another one, CG Power, okay, so that came up in Sanand, Gujarat, okay, so which actually, Professor Goel has talked about already. And so there is another 3, assembly companies have come up. So the last one is, the Morigaon, Assam, so which is a Tata Group company. Now, what I will ask you to remember that, so Sanand, Gujarat has 2 facilities, and Dholera is the chip production plant. Okay, and this is the assembly facility, and you can see that, so they are 100 kilometers apart. Okay, so they are not, next to each other. Okay, so Sanand is a place where the ATMP has come up. Okay, so so this is seems like a technology park, okay, which has come up. Okay, so which is the chip production facility and this OSAT facility, ATMP facility. So they are 100 kilometers apart in Gujarat itself. And interestingly, the 2 factories are Tata. Okay, one is producing chips, okay, and the other is doing the assembly and packaging. So they are located thousands kilometers apart from each other. One in Assam and the other in is Gujarat. Okay, so huge distance to cover. okay, between these funds. Okay, so why I am pointing out this? Okay, so because I'll come back to the experience of Taiwan, okay, which has a developed ecosystem in this. Okay, how Taiwan developed. Okay, so this is exactly not like this, right? So, so this is interesting. And the other interesting thing in Indian development of these things, okay, so all these states, Gujarat, Assam, and UP, Professor Goel talked about. So all these are actually BJP, controlled by the government, which is powered in the central government in India. Okay, and the state governments are also, controlled by the same party. So, all these things. So there is, a shadow of some political decisions, okay, which is there rather than economic decisions. Okay? So that, so that is apprehension. Okay, so that comes to mind. Okay, if you have this information, okay, in front of you. Okay, so I'll come back to this. Now, ATP is a good thing for India because it is a more labor-intensive thing. Okay, so compared to the foundries, so which is much more capital-intensive. So very few labor is actually employed in the foundries. Okay, but ATP is a labor-intensive thing, the assembly and packaging. But the problem is that, so the value of this labor is very small. Okay, even in the ATP production cost, the labor has the value of only 5%, okay, of the total ATP production cost. So therefore, it's not that, lot of income is generated, okay, from the ATP production. If you look at the entire value of the ATP production, okay, so that is happening. Now, so here, in fact, India has competitive edge against China. So because if you look at the labor cost of, China and India, so in fact, Indian labor is still, very, very cheap, okay, compared to China's, because China's labor cost is going up, okay, so in last 10 years, okay, so it has grown like anything. And that is a reason, the China plus policy is working. So while Foxconn, has shifted its assembly from China to India, so probably, to get benefit of this labor cost. Okay, so that is happening. And so there is a good prospect of ATP to be here in India, so because of this low labor cost. Okay, but we have to keep in mind that the value we are getting, okay, out of this ATP, okay, so that is also not much. Okay, so it is 10% of the the semiconductor value chain, and the labor share in that is only 5%. Okay, so that is is very important to remember. Now, what the government policy can do in the semiconductor industry. So here, in fact, Taiwan would be a good example. So Taiwan actually, so look at, the government's involvement, okay, in the industry. And Taiwan is, considered to be a role model in this. Okay, now it started in 1974. So I told you that, the outsourcing of the assembly and packaging. So that started, beginning of 70s and all these things by the by the US. Okay, so to make up for the the reactions of the Vietnam War, so in this region. Okay, but so Taiwan government actually started something, okay, to capitalize on this. Okay, in 1974, though they established two entities. One is ITRI, so which is Industrial Technology and Research Institute. And the second is Electronic Research and Service Organization, okay, ERSO, and they played crucial role, okay, in development of semiconductor industry in India. So what ITRI did, so it was a state R&D agency tasked with fostering innovation and industrial development in high-tech sector. And what ERSO did, so it launched its specific mandate of developing domestic competencies in integrated circuit design and fabrication. So unless you have a skilled manpower and capabilities domestically, you cannot attract technology and FDI, okay, from the outside. Okay, so ERSO actually playing that role. Right, in 1976, ERSO actually negotiated a landmark technology transfer agreement.
20 minutes. So could you try to wrap up so that other speakers have about...
Yeah. Okay, so I'll wrap up in a second. So ERSO played a major role. So actually there was a training by engineers from Taiwan in USA, and they came back, and afterwards many of these people actually opened the factories like UMC and TSMC. Okay, they played major role in this in 1980s. So Hsinchu Science Park, so that was created in 1980. Okay, and that actually created the scope for the industry, the cooperation within the industry, and the interface between academia and industry. Okay, so that's the way, it had a very solid foundational base, and, it maintained a dynamic pipeline of skilled engineers and applied researchers. So, okay, so I skip these things if I have time, so I'll come back to this. So what India did, it created the semiconductor mission and all these things. And, so this Indian semiconductor mission, so that is based on, the promise of subsidy. So $10 billion subsidy, which is given under the Semicon India program. Okay, so therefore, if you, open a semiconductor farm in India today at any of these fabless design, fab or something, the ATP, you will get 70% of your cost will be covered by different governments, either the central government or the state government. Okay, so you have to bear only 30% of the cost. Great thing, but this is the most generous incentive scheme anywhere in the world right now. Okay, so we are spending a lot of money. Okay. And you know that in a developing country like India, so that has a huge opportunity cost. So we are foregoing a lot of things. Okay, so because of this semiconductor industry. Okay, so that is also there, right? There are different incentive schemes. I think Professor Goel has talked about these things in a great detail. Okay, so R&D, so of this $10 billion fund, 2.5% is earmarked for the R&D activity. So that is there, and so this money is also spent for the development of manpower, and we are trying to train 85,000 industry-ready engineers. So they have a ballpark calculation of 85,000. Okay, and so we are trying to develop 85,000 engineers, okay, with the skills to enter semiconductor industry, right? And for that, so we have involved different institutes like BITS, okay, to train these engineers. Right. So right now, there is no tariff to semiconductor value chain. Okay. So because India is a signatory of, so some WTO clause. Okay. So therefore, so there is no tariff for import and export of semiconductors in India. Now, what are the possible, so this is my last slide. So what are the possible bottlenecks? One is electrical infrastructure. So huge stable power requirement is there, okay, for electrical infrastructure. And that is, is a challenge in India. Okay, so we don't have, that, stable grid and, that much of power thing. But renewable energy is coming up in a big way, but we have to keep in mind that renewable energy like solar energy, so Gujarat is a hub of that. Okay, so there are also a lot of intermittency is there. Okay, so we have to think about that. Ultra pure water is needed. Lot of water is needed in this foundries. Okay, so I think Taiwan also there is a problem. So because there is drought, so because you draw water from the other places to use in the semiconductor industry. So that problem is a big problem, water problem. And here also we have opened, the Gujarat is a drought prone area. Okay, but we have all the semiconductor farms located over there. Regulatory role of the government, what Taiwanese government did. So remember, TMC is a firm which is in the foundry, a big firm, but it did not enter into the other segments, right? So there is a restraint, okay, maintained by the big Taiwanese firms, okay, to enter into the other segments of the industry and to create a vertically integrated big firm. So that has happened in Taiwan, but in India, remember that there is an ATP facility and foundry, so both are owned by Tata. So that is a concern, if it may develop monopoly power and slow down the innovation and all these things. Okay, so that trait is there. So stable and consistent government policies. So unless you have stable and consistent government policies, industry cannot grow. The burden of subsidy is too much, and we don't know how to remove the burden. So what happens if you remove the, the subsidy, okay, from these companies? Okay, what will happen? Okay, so that we don't know, and whether we'll be, we'll be able to remove the subsidy at all. So that's a big question. Technical choke points. So semiconductor value chains, so mostly controlled by the US firms, and they have control over the technology, and that is happening against China and Taiwan. So they are saying many things. Okay, you don't do this, don't do that. Okay, so that is interfering with the business. Okay, so that is happening. R&D expenditure by the government, okay, is important. So India is a country which has very low R&D expenditure. Okay, but a lot of promise about semiconductor industry, but we don't know. So if you don't have an R&D environment, okay, how you pick out semiconductor industry out of that and do a lot of R&D in there. And US tariff policy is very uncertain right now. Okay, so right now 0% tariff is there, okay, on semiconductor things. Okay, but there is a threat that 100% tariff will come. Okay, and if that happens, what happens to Indian semiconductor sector? We don't. Okay, so thank you very much. Okay, so I have taken a lot of time because I have a lot of slides. Okay, so thank you very much for your patient hearing. So if you have any question, okay, so you may direct it to Dr. Das.
Thank you very much, Professor Mukherjee. Do we take question answers now? And for how long do we have, Poonam, for question answers?
We
think-
till the end.
Yeah.
After the all presentations, and then we have
The question answers?
right among the speakers, and then we open up Q&A session.
Right. So now are we scheduled for a 10-minute break?
All right. Okay.
It's
Yeah.
okay.
Right. Okay.
That's what the program said. That's why I'm asking.
Yeah, okay. We can start.
What do you think? Do you think we want to continue, or it's better to have a break?
We can have a 5 to 6 minutes break, I think. It's fine.
5 minutes is enough. Yeah. Okay.
I think
5 minutes is fine.
Yeah. Okay.
Okay.
Yeah, because we lost some time, so better to have a 5 minutes.
Yeah. Okay. All right.
We'll come back in 5 minutes.
Okay.
Yeah.
Okay. Thank you.
Thank you.
Okay, are we ready to begin again? Mecca, are you here? Okay.
Megha, are you here? I think she'll be here sometimes.
Yeah, let's wait for her. Maybe we can start. Okay, she'll come in later. So let's shift a little bit from the production industrial development from India to the societal, cultural, political impact. Okay, in between Taiwan-India relations, but also Taiwan-US or US and Indo-Pacific region. So there's societal and political implications are equally important, maybe more important, okay, for us to think the issue and problems that's arising here now, okay. So let me introduce you Dr. Poonam Sharma, who has been here in Taiwan for more than 10 years, okay, finishing her MA and PhD degree. And her major research concern is migration or inequality in for example, her doctoral dissertation, The Invisible Politicized Role and Religious Disorganization of Bangladesh and Nepali Migrants in West Bengal and Northeast India. Okay, she has also worked on this cross-cultural identity formation of migrants, the case of Nepali migrants in Assam, India, and the impact of British colonial period on contemporary India. And her major research concerns in post-colonial theories, border politics, citizenship policies, unauthorized vote bank, okay, and the rising of social political inequality regulated by modern nation state. So that's begin with her perspective on this current India-Taiwan bilateral tie based on this chip makers issue. So Poonam, you can begin.
Thank you so much, Professor Liu. I'll just share my screen. Can you see? Is it shared? Okay.
Yes, yes.
Okay. So before I just start my presentation, I would like to extend my greetings to everyone who is there in this forum today. It's been quite some time that we are talking about semiconductors and about chip diplomacy and international relations, and how these new kind of technological diplomacy shapes or can disrupt relations between nations in the present time. I mean, this is also a quite new topic for me since this year, since we started this project, because as Professor Liu introduced, my studies has been primarily into migration and cultural studies, but it is very interesting this right now. Okay, so in this reference to our whole project, and especially for today's forum, I will be speaking on the topic how chip makers redefine the prospects and problems in India-Taiwan bilateral ties. I mean, too many things has been happening but not quite too many results. But there are so many things happening between India and Taiwan. So I will try to narrate some and how chip is central to all these exchanges. Okay, next. Okay, historical context and growing ties. Over the past 2 decades, India and Taiwan have significantly strengthened their economic and cultural. Sorry, just a minute. My file just got closed. Sorry, just. Okay, over the past 2 decades, India and Taiwan have significantly strengthened their economic and cultural ties. Favorable policies and shared interests have driven remarkable growth in trade and investment exchanges, positioning India as one of Taiwan's primary export destinations and making Taiwan a strategic partner for India's manufacturing hub. That's what all we have been talking about. Since 2016, this is, of course, there were, since 1995, India and Taiwan has established their offices, but for several years, there were no exchanges, nothing between the two countries. It's only after 2016 that exchanges began to take shape. Taiwan's foreign policy has been significantly reshaped through the new southbound policy, although it is seen as an extension of the previous go south policy. It encompasses a broader geographical and administrative scope. This policy aims to diversify Taiwan's economic dependencies away from China by strengthening ties with South and Southeast Asia, and including Australia, New Zealand. And India is also a focal point of Taiwan's external engagements as it seeks new trade partners. Similarly, India has prioritized commercial relationships with Taiwan since the 1990s following economic liberalization. But it's after the India's Act East policy aims to reinforce that strategic financial and diplomatic ties throughout Southeast Asia and the Asia-Pacific region, including Taiwan. So here is a figure of the bilateral trade between India and Taiwan in 2022 to 2023. It's quite latest, and you can see the change in exchanges from 4.72 in 2015-16 to 10.9 in 2022 to 2023. So it's quite high, but still, when you compare it with China, China's engagements with both the countries is still very low. So you can see here China-Taiwan trade and India-China trade, and Taiwan-Indian trade is quite low. So bilateral trade between India and Taiwan has expanded significantly from 2 million in 2006 to 8.224 billion in 2022 to 2023. The establishment of the Taiwan-India Business Association, TIBA, which is quite very active right now in promoting the business exchanges, and the efforts by the Taiwan External Trade Development Council, TAITRA, which has 4 offices right now in India, through its offices, underscore the structural approach to boosting economic exchanges. Despite promising advancements in economic and trade negotiations, challenges persist due to a complex and sensitive geopolitical landscape, as well as structural barriers. In addressing these challenges, these associations do not function as official bodies and have limited impact. And thus we can see that when compared with China, China's trade, Taiwan-Indian trade is still very low. So now I focus on my question, what's India's semiconductor dream and how we understand it vis-a-vis Taiwan? First, it is essential to understand that the Indian semiconductor mission, which is ISM by the Indian government, launched as ISM, initiated by the government of India, is a transformative drive to launch India as a leader in the global semiconductor industry. This mission promotes research and development in the semiconductor industry involving substantial financial investment on an international scale. As a crucial part of this plan, establishing domestic fabs and attracting Taiwanese suppliers would strengthen India's global electronics value chain position and support the government's Make in India initiative. The whole process would drive capital flows, create high-profile jobs, high-value jobs, and stimulate the broader tech ecosystem in India. Moreover, the entire process offers India technical know-how and a depth of supply chain. Most importantly, the whole process strengthens India's software and AI developments in the global order. A recent report by Moody's highlights how India has performed relatively well alongside countries such as Malaysia and Singapore in attracting new global investments for semiconductor projects. The announcements of new electronics component manufacturing scheme in April 2025 may lead to a surge of investments in the larger electronic ecosystem, which may drive upstream semiconductor investments in the country. Now, Taiwan's role. Taiwan's role in the global platform is significant as it is the front runner in the semiconductor industry. The island manufactures around 63.8% of the world's semiconductors, and the 2nm process technology is the most advanced. Of course, we know this is produced by TSMC. It is well known by now that Taiwan remains the global leader in technology and its related research and development in the semiconductor industry. In February 2024, Powerchip Semiconductor Manufacturing Corporation, PSMC, and the Indian company Tata Electronics entered into a venture to invest $11 billion to build India's first wafer fab in Dholera, Gujarat. Gujarat is one of the leading states in promoting and accelerating their work in the semiconductor industry in India. Of course, there are many other states too, but Dholera is in the forefront. This joint initiative between India and Taiwan has laid the foundation for India-Taiwan joint chip manufacturing in India. Now, India's chip friendship. India prioritizes, how much time I have? Just check. Taking 10 minutes. Okay. India prioritizes a secure and consistent semiconductor supply with an additional objective of economic benefits. India imports around 95% of its semiconductors from countries like Singapore, China, South Korea, and others. India intends to self-sufficient with semiconductor manufacturing and an uninterrupted supply chain to withstand the rising competitiveness of progress in technological domains. With its expertise and dominance in the semiconductor industry, Taiwan has a significant role in India's semiconductor ambition. In the future, the India-Taiwan partnership is expected to redefine global supply chains and set new benchmarks for economic collaboration. The partnerships between multinational conglomerates from India and Taiwan are not only working for mutual benefits, but also about less dependency on China and shaping the future of technology and manufacturing on a global scale. Now, geopolitical implications for India-Taiwan Semiconductor Cooperation. This is very crucial. India's cooperation with Taiwan in the semiconductor sector carries significant geopolitical implications, particularly in the context of escalating tensions in the Indo-Pacific region. India's semiconductor industry expansion holds significant geopolitical implications beyond its technological advancements too. By aiming to reduce import dependency and bolster domestic production, India seeks to secure strategic advantages in critical sectors while mitigating vulnerabilities to geopolitical tensions and supply chain disruptions. Collaborations with global semiconductor giants like Taiwan, Japan, and the United States signal a reconfiguration of geopolitical alliances, enhancing India's stature and influence in the global semiconductor landscape. China's claims over Taiwan and to dominate the semiconductor supply chains is another factor. China will add more chip making capacity than the rest of the world combined in 2024, with 1 million more wafers a month than in 2023. This is reported by a report, which I have provided the link in my next slide. By strengthening ties with Taiwan, India can position itself as a viable alternative within the China Plus One strategy, which aims to diversify supply chains away from the reliance on Chinese manufacturing. India's emergence as a semiconductor manufacturing hub could reshape regional dynamics in the Asia-Pacific and foster economic cooperation with alignment among neighboring countries. As other nations observe India's semiconductor ambitions, the technological geopolitical landscape is poised for further shifts and realignments, driven by technological progress and economic considerations. Now, this one, the report that I said, the link is here. So it shows, by 2027, which countries will produce production capacity. So you can see China and Southeast Asia, South Korea, Japan, Americas, Taiwan, and China. This is assumption, of course. Geopolitical stakes and supply chain diversification. India faces a 99.2 billion trade deficit with China, being heavily reliant on Chinese electronics and semiconductors. Taiwan's export controls and US-led chip sanctions on China highlight the need for India to diversify supply chains. India-Taiwan semiconductors cooperation aligns with democratic values and shared strategic interest in the Indo-Pacific. India's semiconductor mission offers up to 50% project cost subsidies to attract fabs and chip design firms. Gujarat plans its first overseas office in Taipei to boost semiconductor and tech investments. IDA's allocation of 48 acres in Noida. This is National Capital Territory attached to New Delhi. For a Foxconn HCL OSAT facility is expected to generate 4,000 jobs. It's not moving. Okay. Strategic and security dimensions. Shared concerns over China's assertiveness in the Indo-Pacific have brought India and Taiwan closer strategically. Taiwan's unequivocal support for India's military operations against cross-border terrorism marks a historic shift in political solidarity. In August 2025, India participated in joint naval exercises with the United States and Japan in the South China Sea, a critical maritime region contested by China. These drills focused on interoperability in surface warfare, anti-air, and anti-submarine operations, underscoring a shared commitment to regional stability and freedom of navigation. Maritime cooperation and cybersecurity are emerging areas for future strategic partnerships. Maritime security, why it matters to India and Taiwan. Indo-Pacific maritime routes are vital global trade arteries, securing them in a shared priority. China's expanding naval presence threatens freedom of navigation near India's and Taiwan's water. Quad's Med3 Initiative 2025, an IPMDA program, enhanced maritime domain awareness, with India playing a key role. These are the shared interests between Taiwan and India. What is India's semiconductor progress at present? A significant amount of semiconductor collaboration is currently underway between India and Taiwan to establish fabrication facilities known as fabs, which of course Professor Vivekananda already explained in detail the works done in these fabs and the prospects. The most extensive collaboration between India and Taiwan is between the power chip, that is PSMC, and Tata Electronics for Gujarat and Assam. This is already ongoing, and engineers and technocrats are already being hired and trained under this collaboration. And I think I should mention this, that the first batch of engineers and fab workers are already ready to leave leave Taiwan and move to India in October. So they will go and start working for the fab design in Dholera. This will be the first group. Foxconn also partnered with HCL to establish a semiconductor manufacturing facility near UP, Jewar Airport, with an investment of $33.6 million. Additionally, there were other JVs ongoing in Gujarat and Surat. While discussing the collaboration ecosystem between India and Taiwan, it is notable that more than 200 Taiwanese companies are presently in India, with prominent being Foxconn, Fangte, and Pochan, establishing large-scale manufacturing units in the country. But there are also companies working in footwear, in toys, working between India and Taiwan, other than the semiconductor competence. It's not moving. What's wrong? Okay. Now, challenges in India-Taiwan chip diplomacy. Despite efforts from both the Indian and Taiwanese governments, India has only managed to attract PSMC, which I just now mentioned, a smaller Taiwanese company specializing in memory chips, to establish a full-fledged semiconductor industry. The failure of Foxconn attempt to establish a semiconductor and display production plant in India in collaboration, which was just a few years back, with Vedanta, highlights the challenges faced by new players entering the Indian semiconductor manufacturing and supply chain. The industry poses significant challenges for new entrants, primarily due to its high capital requirements and the difficulty in obtaining valuable intellectual property. The innovation drive, cost reduction, and an enthusiastic market for new products are making Taiwanese firms more competitive. Considering Taiwan's manufacturing expertise, the semiconductor collaboration enables Taiwanese firms to leverage India's strengths in chip design, assembly, and testing. Now, semiconductor cooperation, a path to strengthen India-Taiwan relations. Taiwan's semiconductor leadership and India's large-scale workforce creates a complementary partnership. India's China plus one strategy in Taiwan's new southbound policy aim to diversify supply chains and reduce geopolitical risks. Geopolitical tensions in the Taiwan Strait pose risk to global chip supply. India offers a stable alternative manufacturing base. The India-Taiwan Semiconductor Forum fostered dialogue on investment, technology transfer, and workforce training. Strategic cooperation can help India overcome infrastructure and ecosystems gaps. Both governments are encouraged to elevate semiconductor diplomacy. Example, Gujarat opening an overseas office in Taipei to attract tech investment. While conclusion, semiconductors are not just economic assets, but a bridge to deepen India-Taiwan ties amid regional complexities, offering a win-win path forward. Now, at present, 2025 marks 30 years since the India-Taipei Association was established, fostering multi-sector cooperation. PM Narendra Modi's personal connection to Taiwan and emphasis on tech lessons signal a new era. Of course, the whole Semicon India and other initiatives. Despite decades of relations, semiconductor collaboration has been developed at a very slow pace in recent years. Now, since we are all into academics and we're talking about, we're in academic event, I just put a list of literature review here. And thank you so much.
Okay, thank you, Poonam. Thank you so much. Let's move on, okay, with our final presentation by Dr. Megha Srivastava. Maybe you can share your screen now. Megha now currently is a Taiwan Fellow and Visiting Scholar under the program of Ministry of Foreign Affairs, affiliated with the Institute of National Defense and Security Research in Taipei, Taiwan. She is currently a doctoral candidate, I think, in the Department of Geopolitics and International Relations, Manipur Institute of Social Sciences. And she's specializing in the areas of technology policy, great power competition, China's ICT policies, and sound track record on research of China's ICT policy, semiconductor supply chain crisis, and AI governance. And she recently also analyzed the Trump administration earlier banned the sale of NVIDIA's chips, but now seems to relax the ban. But we're very happy to have her presenting her view on decoding India-Taiwan semiconductor cooperation, constraint, calculation, and missed opportunity. Megha, the floor is yours.
Good afternoon to one and all. It's a pleasure meeting you all. Just to make sure if I'm like completely and clearly audible to all of you, if you may, yeah. Okay. Yes, I have completed my PhD.
You are not sharing your screen yet?
Actually, today I'll be speaking without slides. I have a structure in mind and maybe I'll explain. So, yeah. I'm a fellow or visiting scholar at INDSR Taipei and have been working on Taiwan's semiconductor industry. I have conducted several interviews in Taipei and Hsinchu with both people from the industry, from the Taiwan's academia and journalists. I'm trying to collect domestic perspectives on Taiwan's challenges, recent challenges in the global supply chain. And today I'll be sharing some of my assessments and observations in India, Taiwan semiconductor ties in the past few years. So my talk is designed as I will first contextualize my research and then I'll move on to critically assessing India-Taiwan semiconductor ties, understand whether there are some constraints or not, and if there are constraints, there must be some calculations that both countries are pursuing, and what could be a way forward for this. So to contextualize my study, I want to reiterate what Dr. Joyce said in the beginning of this talk, that how semiconductors are everywhere and how they are important in the global rivalry. In the broader context, if we look at the US and China tech rivalry, it's not just about trade wars or military bases anymore. It's about who controls the most advanced chips today. A few years back, we heard this very popular phrase that whosoever controls AI, they control the world. But this rapidly intensifying US-China chip rivalry testifies this and also narrows it down for us that it can be said that whosoever controls semiconductor technology, they control artificial intelligence, quantum computing, 5G networks, missile systems, etc. Now, all of this anxiety focuses on a narrow waterway that is Taiwan Strait, and this is where Taiwan's position in the global supply chain is important, as it is a choke point. And if it gets disturbed, it has wider implications for the global supply chain that could shudder in that case. And COVID-19 has already has given us a taste of this fragility in the global supply chain. For this reason, there
for 1 minute, Megha, may I just interrupt for a second? I think Poonam needs to stop sharing her screen because
I'm not sure. Yeah. Is that
sorry. It's still sharing. Okay.
Yeah, it was still on the sharing
stop
mode.
Sharing.
So
you are
it
sharing
okay
your
now?
screen, everything. All right, go ahead, Megha.
Okay. Yeah. So yeah, I highlight, I was at the COVID-19 situation, that how it has highlighted the gaps, the vulnerability in the supply chain. And for this reason, this technology itself is being securitized by many countries by both ways. First, by way of export controls, also by way of industrial policies. As we have seen, various countries have come up with new policies to subsidize industrial policies in support of the development of domestic semiconductor sectors. For example, US has come up with Chips and Science Act. In EU, we have seen this $40 billion policy mechanism at place. The previous panelists have also highlighted India's semiconductor mission and the $10 billion investment that it has promised. For all these reasons, in India-Taiwan chip ties are not only mutually exclusive, but they are also crucial in the larger geopolitical context, in the Indo-Pacific context, if I focus on that point. And again, given this choke point and the position of Taiwan in the global supply chain, we can say that Indo-Pacific presents as a region of opportunity, both as a competition. And if we talk about India-Taiwan ties, it's not only about contested waters and disputed borders in the Indo-Pacific context, but it is also about the circuit boards now, the semiconductors, the supply chain that run silently underneath the surface. Now, if that is the global picture, let me zoom in the India-Taiwan story. In the last few years, the nature of ties has definitely strengthened. It has deepened in many areas, be it university to university contact, be it people to people contact, be it private to private collaboration, or be it private to university collaborations. So yes, governments are very clear that they have a logic to cooperate. Logic is that India is a huge market for Taiwan. There is domestic demand when it comes to legacy chips and India has talent, and Taiwan obviously has the superior technology to offer to India. So based on this logic, this collaboration has heightened up in the recent years. For example, if we look at the university to university collaboration or the private to university collaboration, in recent years, there are dual degree models and credit transfer models that have come up in terms of collaboration between these two countries to bridge the talent gap, especially in technologies like VLSI and advanced chip designing. When it comes to universities, there's NTHU in Chinchu itself, which collaborates with India on semiconductor physics, material science, international internships. Also, they're offering to Indian students. The focus of research in such kind of collaboration is mainly on chip designing. Some part is also focusing on photonics and power electronics. There's a collaboration of IIT Madras and NTHU on these areas. So yes, university to university collaboration is strengthening in recent years. When it comes to private sector involvement, Taiwan Research, ITRI, and India's Ministry of Electronics and Technology is actively involved through Electronics and Semiconductor Association. Also at Semicon India events, several MOUs have been signed up between countries to come together and collaborate on chip designing facilities. There are agreements between Foxconn and Indian states, for example, Tamil Nadu and Karnataka, that include components related to skill development. So Taiwanese companies are also involved in India's semiconductor mission when it comes to training India's talent. So this is a very important emerging space in India-Taiwan partnership. That is skilling Indian talent in Taiwanese universities and sending them back to India to specialize in certain segments. And these segments are mostly in either advanced packaging or advanced chip designing facilities. However, though all these developments are racing their pace, the execution historically has been slow. It has been very cautious in its approach, and sometimes it's also frustrating, as previous panelists have highlighted, due to failures of certain agreements being called off. All these, I want to say that all these remains at a very nascent stage, and we are looking forward how it grows in future. There are various constraints as delegations have flown from Taipei to India, from India to Taipei. Companies in India have tried to quote companies in Taipei. However, we have seen a series of cautious steps from the geopolitical angle. If we say that Taiwan is cautious of engaging with India due to various factors, one of them is the China factor. However, there are smaller firms in Taiwan which have shown interest in India's semiconductor industry, for example, TSMC. But the important is the fact to understand that why bigger players, for example, TSMC, is still hesitant to invest in India's semiconductor sector. So when we ask why has not India-Taiwan semiconductor cooperation taken off the way it should, the answer is not lack of will. It is about certain constraints that Taiwan's chip makers face when it comes to doing business in India. Topmost, in my opinion, is credibility of India's infrastructure, its work culture, its ability to deliver, which is constraining Taiwan's chipmaker to invest heavily in India's semiconductor industry. We already have the example set of Vedanta and Foxconn project, which collapsed. Deals like this not only affect the financial plans or investments of India, but they also make Taiwanese firms pause when it comes to the approach of investing in India. Also, secondly, there's a capability mismatch when it comes to India's capability in the semiconductor industry and Taiwan's capability. One of the topmost examples, in my opinion, comes from the recent case of TSMC's decline of refusal to invest in India's semiconductor industry or to set up a plant in India. Why? Because India is only taking a baby steps as of now, and it is not experience. It does not have a established ecosystem to cater to the advanced packaging needs. Advanced manufacturing needs that TSMC expects. TSMC is at the bleeding edge of semiconductor manufacturing, that is 3 nm, and India's potential is limited when it comes to manufacturing, limited to foundational chips only. So TSMC's interest lies in leading edge segments, and they do not want to produce lagging edge technology in India, because mostly when you go out and you invest in other countries, it is targeted to meet the domestic demand and not for exports. This is also the reason why TSMC's interest remains very high in countries like the US or Germany or Japan, where they could meet the domestic demand, and it's not in India. So this is one of the reasons which is highly coming from the industrial perspective and not the geopolitical perspective. Also, in my conversations with people in Taiwan, almost all of them highlighted that how India's infrastructure does not look well or present a very good picture in the eyes of the Taiwanese manufacturers. So to run a fab, you need uninterrupted electricity, gallons of ultra-pure water, reliable logistics chain, dozens of supporting supplies, which India is still in the process of making but does not have it in place. So Taiwan has built this ecosystem for decades. However, India is still beginning that phase. So these basics are still patchy in India's scenario, in its ecosystems. There are cases of power cuts in Gujarat. There are cases of water shortages in Maharashtra. Both of these are geographically located in a place which are fragile when it comes to its geology. So these are not just inconveniences to set up a semiconductor plant, but these could also be deal breakers for us, for Indians, when it comes to expecting Taiwanese firms to set up their fabs in India. Also, there's a coordination problem when it comes to Taiwanese side and Indian side. There are different ministries in India, there are different state governments, there are various agencies dealing with one project, and this looks extremely complicated to Taiwanese manufacturers or chip makers. Sometimes they are competing with each other. In India, the actors, when it comes to governments, state governments, I mean to say, chip makers, they are competing with each other rather than working together. So, also on Taiwan side, there are a few problems that there's no single decision maker. The coordination between the government and the private sector also remains limited when it comes to making decisions to invest outside. So there's a lack of clear channel that slows down the whole process of investments. So these are the few constraints that are so far limiting a deeper engagement between these two countries. However, despite these, the fact it cannot be denied that India-Taiwan cooperation in the semiconductor sector is going up, especially in recent years when this global supply chain and US export controls and US-China chip rivalry intensifies. And one of the recent examples that we have a solid agreement or joint venture between PSMC and Tata. However, there are certain calculations which both countries are or have in their mind when it comes to deepening their cooperation. For New Delhi, as Poonam pointed out in her presentation, that there are around 95% dependence of India on foreign imports when it comes to semiconductors. So there's a quest which is rising when it comes to gaining independence or independent capabilities in semiconductor manufacturing. So India is very clear about its goals that it needs to build a local chip ecosystem, and even if it takes time, it has to start small. And when it looks forward or looks outward for partners, Taiwan is the most natural choice that India has. For Taiwan, these calculations are a little different, but however, they remain equally strong. Taiwan lives under a constant pressure from Beijing, and due to this global chip supply chain diversification and the post-19 phase, the pressure to diversify is very much visible in Taiwan's policies. So it has been reaching out to Vietnam, to India, to US, to Japan, to European countries, etc. And India should be a clever choice. Also, there are external factors. For example, the US factor. Washington does not want to reshore semiconductor production at home only. It also wants allies to share the burden of securing supply chain, and India could be a viable option given its position in the Indo-Pacific framework. So often we have seen that this is the reason why sometimes these trilateral conversations or American officials are quietly encouraging Taipei and New Delhi to build and deepen their ties. However, calculations come with some cautions also. India is balancing its relations with Beijing also, and Taiwan knows that putting big money into India could be risky also at times. So it is also looking at actors like Vietnam, Malaysia to diversify its position in the value chain. So here we get a picture that the convergence exists, but it is strategic. It comes with cautious pacing when it comes to positioning their relations, their bilateral ties. Both India and Taiwan are very clear that they want to work together. They see the logic, as I said earlier. They are constantly measuring the risks, though. There are hesitations, there are major hesitations, and due to which some opportunities have been missed. First is, I think I've already talked about the Foxconn Vedanta deal, that it has dented credibility of India as a manufacturing base earlier, and for Taiwan, it reinforces the image that India is still in its nascent phase. India is still a difficult place to do serious semiconductor business, and it hinges on India's prospects in moving up in the value chain. Second example is the TSMC's decline to set up a fab in India. Other than the reason that there is a capability mismatch, another reason is that which goes again beyond the geopolitical calculation, is that TSMC's outward investments and model expects sufficient domestic demand, which India is not able to cater to. India's manufacturing is mostly in the legacy side. It's not consuming 3nm or 5nm chips as it is consumed by chip makers in the US, because it has bigger firms. So the kind of chips that TSMC wants to manufacture, India is not consuming it. So this demand-supply mismatch is also a factor due to which India has missed the opportunity. Over the years, India has also sent thousands of delegations to other countries, several delegations to other countries in US, Europe, and also Taiwan to train its talent. However, we have not been able to establish or attain a level where we have structured India-Taiwan semiconductor educational talent pipeline. So because of this pipeline or structured way of sending workforce or exchanging workforce in each other countries, a lot of potential or time has been missed so far. So India has hesitated, and in the meantime, others have moved forward. For example, Vietnam and Malaysia have deeper ties, also Singapore, when it comes to training their talents in Taiwan. Given that, I think all these missed opportunities have critical lessons for us to learn from. The lesson from the Foxconn failure is that India needs to move faster and cut through their red tape. We need to make sure that doing business in India gets easier, especially in the fab and the manufacturing sector. From the TSMC case, there's a lesson that India needs to work on the basics first. Maybe there's a need to focus on ecosystem planning, preparing ourselves for the semiconductor industry first, and maybe a best way to build more capabilities in the design and the assembly, testing, and packaging sector, which India has more potential to demonstrate its capabilities in. So there's a need to build credibility. Let bigger fabs from Taiwan flow in when our ecosystem is ready. Another thing is that from the talent gaps that exist between India and Taiwan, we need to strengthen people-to-people ties. It is as important as government schemes or providing subsidies to Taiwanese chip makers. The failure to attract TSMC and other major fabs from Taiwan should give us a lesson that subsidies are not the only thing that Taiwanese firms are looking for. They are also, and promises are not sufficient. We need to establish credibility, we need to give results, and we need to furnish successful cases first before expecting firms like TSMC to invest in India. So there is a need to have a lot of dedication when it comes to setting up structured facilities between India, Taiwan, be it talent pipeline or be it special economic zones, particularly catering to the semiconductor industry. So if India can create this plug and play facility with guaranteed power, water, logistics related angles, it could reduce the risk that Taiwanese people or Taiwanese firms see in investing in India. It can be said that Taiwan and India both have true logic in their cooperation. The question is not whether they should strengthen their cooperation in this particular segment, that is semiconductor industry, but whether they can do it fast enough and boldly enough to matter, because there are geopolitical challenges, there are industrial challenges. So given this, we can say that yes, the semiconductor world is changing really fast, and the US, Europe, Japan, Vietnam, and even the Middle East, everyone is building capacity. So India is also in this race. So we need to make sure that India and Taiwan's pace of growing their ties in the chip sector needs to grow faster, and while supply chain solidifies themselves, India and Taiwan needs to make sure that this chance should not slip away to another years or another decades, as it has had in history. So I'll rest my case here, and if there are any questions, I would be happy to answer.
Thank you so much, Mekha, for your excellent analysis, rather critical and realistic. So let's open up, Rosinka, shall we? Open up conversation first among the speakers. Okay, speakers, you may, you're welcome to raise comments, questions, or critique for one another before we open up for general Q&A session. Right. Yes.
So
Yes,
I have a
yes,
question for Megha, right? Yeah, two questions. One is that why do you say that, the foundries, okay, the semiconductor production decision should be, guided by domestic demand. So because you can, this has happened. For example, the chips produced in Taiwan, so mostly, exported to the other countries, right? And that's the way it happens. It's not that, it's the entire chips produced by TSMC and, other companies. So they are consumed in Taiwan only, right? So it's all over the world. So it's exported. So therefore, why are you saying that, the industry should look at domestic demand? So that's the first question. The second question is that, so probably you're ignoring or, downplayed the security risk of Taiwan. So I think one of the strengths of Taiwan right now, so I may be wrong. So but my reading is that, so one of the strengths of Taiwan in security front is the semiconductor industry, because this is a choke point. So since, you are producing almost all of the, the smaller chips, 7 nanometer and below. So therefore, so if there is a collapse of production facility in Taiwan, the entire world is under risk. So that is a security for Taiwan. So if you give up, so if you produce somewhere else in US and, in India or Germany, whatever it may be, so you are giving away that, that security that you have, right? So have you thought about this angle, So that maybe, when we are saying why TSMC did not invest in India, so that can be one of the reasons also. So these are the two questions.
Mekha, you can.
I'll right away answer these questions. Your first concern regarding why TSMC would say that it would not invest in India because of the lack of domestic demand. I have talked to people in Taiwan itself, so it's not only my assessment that I'm saying it from. It's not only my opinion, but wider industrial perspective says that when you offshore facilities outside your country, it is largely dedicated, or it is aimed at meeting the domestic demand. So yes, when TSMC produces, it is being exported. But when this Arizona firm is being established in the US, it is not aimed at further exporting the chips to maybe India or some other countries. So this is their business model. TSMC looks at sustainability in the long run. And if, for example, if they establishes a firm, because they are targeting only at the higher nodes, not at the 48 nm or the foundational chips. When they go out, they will establish firms which are dedicated to producing 5 nm chips, for example. And they don't think that India is ready to establish a fab which could produce higher nodes. Secondly, it does not have a market which could consume 5 nm chips, all of which they could produce. If something goes wrong, if you establish a firm in India today, and if something goes wrong down the years, 4 or 5 years or 2 years later, for example, what happened with the Foxconn case, it would be too risky for firms like TSMC to invest in. So yes, they have a model which they themselves justify that India is not yet a place to work on, especially in the higher nodes. Yes, in the foundational chip nodes, or for other firms in Taiwan, I would say that yes, India is a market, and there's a huge domestic demand to cater to. Secondly, I guess precisely you raised the issue of Taiwan's criticality in the supply chain when it comes to the idea of silicon shield. You must have heard of that, how crucial it is. And because of its diversification outside Taiwan will hinder its security in the long term. First of all, this idea itself remains disputed, that maybe, it is more to be discussed in Taiwan's parliament or among politicians in the executive yuan or something. But not many chip makers, for example, TSMC, are considering these security factors when it comes to going out. Secondly, when it comes to going out and this larger narrative of hollowing out Taiwan's security interest if they go out and invest, for example, it's Arizona firm. They say that they are not hindering the security of Taiwan in the long term because they are not moving out technology which is crucial for Taiwan. They are not passing out or passing on security codes which would ultimately hinder Taiwan's position in the supply chain.
Yes.
Yeah.
Thank you.
Pranab, you have any comments or question?
Not really.
I have a question for
Yeah, please.
Professor Vivekananda, because in your presentation, one of your slides, you showed that demand in India is going down while the production has increased. And in the past, it was something else, but now it's like demand has gone down and production is high. Is it because of the cost problem? Because there are many reports say that production in India is not cost effective, and that's why people in India, like the local crowd, they still rely on the cheaper products imported from outside. Is that a problem? Do you think that?
So I think a question should be directed to
Okay.
Professor Pranab.
Okay.
Anyway, so if I will come back, I can answer your question, but let my co-author, to answer this question.
No, but which slide you are referring to?
I don't know, but there was
So
a
actually, Pranab, I can answer this question. I think,
Yeah.
slide you are referring to. So that actually, it's not reduction in demand. So what I showed in the slide is that both the demand and supply production, both are going up, both are growing, but the production is supposed to grow more than the demand. Okay, so as a result of that, so that creates a lot of potential for exports. Right, so if you produce more than domestically, more than the domestic demand, okay, so then rest of the things you are exporting to the rest of the world, and that is precisely what is happening in the mobile manufacturing and all these things. So in India, a lot of assembly is happening. For example, Foxconn, again, another Taiwanese firm, so it's assembling, taking out its assembly from China to India, and as a result of that, it is exporting the Apple phones to US. So Apple phones are assembled in India not because of domestic consumption. It is exported to US. So it's not that the demand for mobile phones is not going up in India. So in fact, the huge populations, a lot of penetration of mobile phone, huge demand for mobile. So that is going up. But at the same time, production is going up at a higher rate, and the excess amount is exported to the US or other countries. So that's, I hope I have clarified your point, right?
Yeah, and I have one more question for Professor Das, because you're very actively looking into the Indian perspective of into the semiconductors and the problems and prospects, why it is not moving forward. And the Dolera, the initiative is almost like ongoing. It's in somewhere middle. It has taken off, and there are trainees getting trained, and there are already people staying in Dolera for fab design and everything. So are you optimistic about this initiative?
No, it's not a question of opportunistic. It is working now. And they are, as one of the slides showed, that these are not, actually these are legacy chips, which India will be requiring a lot in the future also. So that is okay. But the thing is that what happens when you don't get enough of trained personnel in India? So I am not very hopeful about overall scenario. Dolera project will probably work, and they have sent, in fact, a lot of people to Taiwan, Taipei, for training, etc. So that will probably will work. But what will happen in future? That depends. It is very difficult. Astrology and forecasting are almost same. Statistical forecasting. So it is very difficult to say, because a lot of things can happen in future. One thing that has worked probably in favor of India, among other things, that will probably work on in the November 26 book project, is that, see, at US administration, because of China threat in the South Pacific and Indo-Pacific region, is very much giving these things to China. And China has invested a lot in these sectors, in human capital, everything, but still quite off from this very small chips, which are very important for really the new security, etc. These things. Now, but in the process, mostly this, particularly in EDA, electronic this thing, which is the brain of the chip, where there are only 3 companies in US and 1 company in Germany. So, but they are major. So over 60% they supply to China. Now, if that is stopped, and then US national objective or the global security objective might be fulfilled, but the companies are losers. So that way they can come to that. Another opportunity has come up if India becomes one of the places. This is another perspective. We'll talk about that in later.
Okay, so I commend just one, So the other thing, I am hopeful about this PSMC and Tata thing. So because to me, parallel to training of Taiwanese engineers in US in 1970s, and that actually benefited Taiwan a lot. Okay, so these people actually, came up with UMC, TSMC, and all these things in 80s. So if similar thing can happen in India. So if I'm not sure, because now what is happening, PSMC, so this training is taking place at a technological ladder at a much lower level. So 28 to 90 nanometer chips, so not at the cutting edge technology. So the thing is that, so the kind of advantage the India will have, so maybe in the, opening up other firms in the 28 to 90 millimeter technology, unless so there is a complementarity between these legacy chips and the more advanced chips. I'm not sure, so because I'm not technology background, I don't know how much complementarity is there. So but if such complementarity is there, so then probably using this, India can move up in the technology ladder. So that possibility is there, but we have to get more information about that.
Professor Maju, would you like to join the conversation?
Yeah, it would have been better if Professor Goel was here, but nonetheless, so it's very interesting to see the different viewpoints from the Indian and the Taiwanese side. My 2 cents in this discussion, which I'm actually taking up in my paper for the book project largely, is the India's comparative advantage in the rare earth elements. Because so far what we know is that India is a third in terms of ranking in the sites of rare earth elements, is after China and Brazil. So China is certainly the huge market for rare earth elements when it exports, when it has a very different deposits, deep deposits. But what India can explore is the rare earth elements, which was not there in the discussion today, because I think that's a very geopolitical strength that India has, which India should explore much. And I'm also thinking in terms of the academia's role, in terms of this the disciplines of geopolitics and metallurgy. Particularly, India had this long tradition of the Indian School of Mines and all. That can be another thing. But what the problem here, I guess, is whether there would be real critical technology investments in India, which our economics friends have been looking at, that there is some kind of not a very positive sign so far. And this whole what Metha was also suggesting, the Vedanta deal, that problem that happened also, is it possible that even if the rare earth elements deposits are explored, is India going to be a more of a mining sector based kind of country, where in the supply chain it will only provide raw materials, but the technology part will be taken care of by the Chinese or the Taiwanese? I think that is something which is really a concern for me. So the production part, whether Indian companies will be that able to create that level of scale, I'm not very sure. And also, given the point that what Vivekananda Mukherjee was suggesting in his presentation, that so far the investments have been done in the ruling party, where the ruling party is at the center and the ruling party at the state. It is possible because maybe the bureaucratic bottlenecks are there in other states where the ruling party is different from the center. Although there have been some investments of at least some kind of initiatives taken in Odisha and in South, and even the announcement is there in Bengal. And Bengal, before Trump came to power during the Biden administration, August, September, there was this whole announcement that there will be some semiconductor industry coming to West Bengal. West Bengal in contrast, is in a comparative advantage than Gujarat on the water supply thing. Gujarat was a drought-prone area, as Vivekananda Mukherjee was suggesting, where West Bengal is not a drought-prone area. The recent discussion in the Rajya Sabha suggests by one of the questions that Bengal has actually deposits of 140,000 crores of rare earth elements. Now, whether these can be explored in the long run, that is, I'm not sure. Although, because the trajectory of Indian big capital is that 60% of their earnings come from rent-thick sectors, which is mining, real estate, and all. So I think it is possible that this can be explored, but I'm not quite sure whether India will only become a supplier or an explorer of the rare earth elements than to actually produce it in the country. So that's my kind of comments and provocations in this discussion. Thank you.
Yeah. Maybe my final question, I still am curious about Mekha, how you assess this current situation. You mentioned there's the issue of talent or ecology, pure water resource, and also maybe governmental, maybe bureaucratic processes or inefficiency and so on. In addition to this lack of talent and so on. So compared to or contrast to China, so how do you compare the constraint in India with this highly efficient progress in China in this producing this highly advanced chip, right? I think those are the key issue now, right? So what do you think? Or maybe whether India could overcome this constraint in the coming years?
Okay. Speaking of a comparison between India and China when it comes to strengthening business environment to support semiconductor industry, I would say that the role of local governments in China has been particularly instrumental. It's not the same way in India. We have not been able to allocate resources as China has done, because in China, when it comes to provincial and local governments and their facilities to domestic, private, or SOEs, there's a intense subsidy competition that runs and that benefits local businesses. Not even local businesses compete with each other to get those subsidies, but also local governments compete with each other to provide those subsidies to their chip makers to meet certain
Your connection is not
targets. However, there is adoption mechanisms currently remain weak, because when it comes to semiconductor policy, it's mostly exists on the state level and the central level. I'm not much aware about Dholera's case and how the local government is involved in it, but it is certainly different than what it is in China. And maybe it could be a lesson to learn from it. But however, I wouldn't say that the model in China is replicable in India because of extreme differences in the political setups.
One party will the state.
Yes, because democracies have their limitations. Taiwan would know it better.
Yeah, right.
So yeah. So yes, when it comes to learning or how India could overcome it, I would again say that more reforms are needed on the grassroots levels to ultimately create a business environment which is suitable for a manufacturing industry. Because India has done historically fantastic, I would say, when it comes to setting up or providing its outsourcing its human resource, especially in the IT sector, which is it is known for. But in the manufacturing sector, as compared to other countries which have huge potentials, example China, we have lagged in several ways. And manufacturing sector is one where we need to undertake massive reforms to support development at the ground level. That would ultimately have effects on, for example, you mentioned water or electricity or power. All these factors will collectively make an ecosystem which is suitable for semiconductor production. I'm not saying that these are currently ultimately non-existent in India right now. Yes, there are policies which are being taken up to facilitate all these, but there are factors wherein more reforms are needed to facilitate these. Even in Taiwan, there are problems related to water and electricity to facilitate TSMC's functioning. So yes, they exist everywhere. So India is yet again another country which is in its nascent phase of policy development, and there are these challenges that that policymakers need to focus more on, other than subsidizing only fabs.
Thank you. Rosinka, you have some final words or comments? Unmute yourself first. Yeah.
Yeah. No, thank you so much for a very stimulating morning. I am not an expert in the area, so I learnt a lot. It is a subject that dominates our newspapers and general conversation maybe, but it is not something that I at least personally knew about in as much detail as I have learned from all of you today. So thank you very much for all your presentations. And yeah, I hope this project results in, and I think it will from the presentation certainly, in some very interesting work going forward. So thank you. Thank you, Joyce.
Thank you, Rosinka. Thank you for your team. And Monday next week on the 8th of September, Mekha will also do a solo presentation, more of a thorough analysis and of the issue. And then, of course, the event that will come up in this semester on other issues like smart cities, sensors, biometric sensors, smart borders, and digital ID and digital platform and gig work and so on. So we are also moving forward to what chip can do, advanced chip, okay, artificial intelligence can do to human societies. So I welcome you to join our discussion. Of course, in our November workshop and field trip, you can have a more direct conversation with our STMC and Narrow Lab experts and also other researchers. So see you next time. Okay, bye-bye. Thank you.
Thank you so much. Thanks, Joyce.
Thank you. Yes.
Thank you. Thank you.
Bye-bye.